All right, we'll wrap up this set of notes with two more examples. Problem number 2, I'm asking you to find the x-intercepts. So that just involves doing some algebra, and then we're going to see how Rolle's theorem will guarantee that in between those x-intercepts, there is either a maximum or a minimum. In other words, a place where the derivative is equal to 0. So finding the x-intercepts will set the original problem x squared minus x minus 2 equal to 0. And you can split the middle or just do some guessing and checking to factor this. So once you get it factored, you'll find out that it is x minus 2 times x plus 1 equaling 0. And then setting each one of those parentheses equal to 0, we would get the x equals 2 is an x-intercept, and x equals -1 is an x-intercept. So that accomplishes the first part of this. We have found the two x-intercepts. And by the way, this is a quadratic, so we have a parabola. So you can visualize this parabola opening up, and so it would have a minimum value. But we now know that this minimum value is guaranteed to be between the x-intercepts because we actually have Rolle's theorem applying. We have our endpoints being our two x-intercepts. So we're actually showing that between -1 and 2, between our two x-intercepts, we have a continuous function. So f is continuous. I'm just going to abbreviate there. And it's a parabola. So f is differentiable. And we found out that f of -1 is equal to 0 because it's an x-intercept, and the f of 2 is equal to 0. So that means that f of -1, or f of a, in other words, is equal to f of 2, is equal to f of b. And so Rolle's theorem does apply. So there should be a place where f prime is equal to 0. So if we do our derivative, f prime of x is equal to 2x minus 1. And if we take 2x minus 1 and set that equal to 0, we get that x is 1/2. And we can look to see, is 1/2 in the interval between -1 and 2, and yes, it is. So 1/2 is in the interval from -1 to 2. And that is the place where f prime of x, or f prime of 1/2, is equal to 0. Okay, so that's what it asked us to show, and we knew that we at least would have this one place because of Rolle's theorem where that happened. All right, and then my final example is about the mean value theorem. On the mean value theorem, it says that you have to have continuity and differentiability. So I have a square root function for us to look at. We're on the interval from -7 to 2. So we just need to make sure that we clarify that f is continuous. A square root function is continuous. Those functions usually look like something like this. And so it's continuous It is also differentiable. There are no sharp turns on a square root function. So it is also differentiable. And again, I'm just going to abbreviate that. We have no other conditions. So you can state that the mean value theorem, which I'm going to abbreviate as MVT, the mean value theorem applies. So we do not have to do anything with f of A or f of B. So if the mean value theorem applies, then our derivative should be equal to the slope of the line that goes through the endpoints. So you basically have two things to find. You first of all have to find your derivative. So let's do that. F prime would equal, now remember that maybe I want to do a rewrite real quick here. F of x is 2 minus x to the 1/2 power. So f prime would be 1/2. I want to keep my parentheses 2 minus x, subtract 1 from my exponent, so that would be to the negative 1/2 power, and then multiply by the derivative of the inside. So the derivative of negative x would be negative 1. I might want to clean that up just a little bit. So it's negative 1 times 1/2. I'm going to put that negative 1 in the numerator. I'm going to put the 2 in the denominator. And since I have a negative exponent and it's a fraction, I'll write it as a radical in the denominator. So f prime of x is equal to negative 1 over 2 times the square root of 2 minus x. All right, so that's one piece that I have to find. Then the other piece that I have to find is the slope of the line that would go through the endpoints. So that's this f of b minus f of a. So your interval is from negative 7 to 2. So f of b, f of 2 minus f of a. That would be f of negative 7 over, and then b minus a. So 2 minus negative 7. All right, so I'm going to have to do a little math here. F of 2, that means that I'm going to, I'm just going to go ahead and do the math right in here. Plug in 2 for my x, so 2 minus 2 inside the square root. And then f of negative 7, so that would be 2 minus negative 7 inside the square root, over, and then 2 minus negative 7, which would be 9. So my slope would be the square root of 0. Square root of 0 is 0. Minus the square root of 9. That would be 3. And then over 9. And so my m is negative 3/9, which reduces to negative 1/3. Okay, so now that I have found those two pieces, according to the mean value theorem, then there must be an x where those two pieces equal each other. So in other words, I need to find an x where negative 1 over 2 times the square root of 2 minus x is equal to negative 1/3. Now, you can solve this problem in a variety of ways. You have, first of all, you have two fractions where your numerator is negative 1. So if your numerators are the same, then your denominators would have to also be the same. And so you could just set your denominators equal to each other. Or you have a fraction equals a fraction. You could cross multiply and solve. And I think I might look at it that way with you because that's more likely what would happen on other problems. So I'm going to cross multiply it. I would get negative 3 and then equals -2 times the square root of 2 minus x. And then I'm going to divide both sides by -2. So that'll give me +3/2 equals the square root of 2 minus x. I can square both sides to get rid of the radical sign. So squaring, I would get 9/4 is equal to 2 minus x. I can subtract 2 from both sides. So I'll continue that up here. So 9/4 minus 2. All right, that would be 8/4. So 9/4 minus 8/4 would give me 1/4. And so 1/4 is equal to -x. So positive x would be equal to -1/4. And -1/4, according to the mean value theorem, should be in the interval between -7 and 2. And it is. So I wanted to show you with this last problem what you found. So you found that you had a slope of -1/3 for the line that connected the two endpoints. So keep that in mind. Your slope was -1/3 for the line that connected the two endpoints. And we found out that when x was -1/4, that we should have a derivative. So in other words, a slope of a line that would be equal to -1/3. So now I'm going to clear the ink and let you see the graphs. So on Desmos here, the red graph is your original problem. That's the square root graph. And then I went ahead and found what the equations were. So the green equation, or the green line that you're seeing here, this is the line that connects the two endpoints. And the slope of that line is -1/3. And you could check that out, and that is actually this equation right here. So the slope of that line is -1/3. It's the line that connects those two endpoints. And so what we found is the x value, and that x value turned out to be -1/4. So notice this point right here, the x is -1/4. And we have a tangent line. This is our blue line that is running through -1/4. And notice that that tangent line, which is this equation right here, has the same slope as the secant line, the line that ran through the two endpoints of our graph on the interval from -7. Because remember, our interval was from -7 to +2. So this is that mean value theorem. And I thought it was important for you to at least have a visual of what you were able to find. So you found that x value that gave us a tangent line slope, which was equal to the slope of the line connecting the endpoints. So there you have a good visual, I think, of the mean value theorem. Rolle's theorem, the visual of that is basically that you have a horizontal tangent. So those are where you have maxes and mins in the interval. All right, so those are your two important theorems. Make sure that you know all the conditions as well as the conclusions for both Rolle's theorem and mean value theorem.